So continuing with solving equations, we have this next one, and you notice that it's set equal to 0. And again, I want to look at the graphical aspect of it first. So I'm going to call the entire left side y, and I'm going to basically graph y equals x sine x minus sine x. And just so you see what it looks like on Desmos there it is. All right, so I'm just going to hide that. And notice that when y equals 0, the special points we're looking for on the graph are the x-intercepts. So the x-intercepts correspond to the solutions to the equation. And remember, I only want the solutions from on the interval 0 to 2 pi. So if I just touch these here, notice that there is one solution at 2 pi. We don't include it because it's 0 bracket 2 pi parenthesis. Notice that the solutions appear to be 0. And here's something interesting. We get x equals 1. That's it. That's different. And x equals pi. So now that we see these solutions graphically, let's go back and try to get them analytically. So here we go. So coming back here, I'm going to get rid of this now because I don't need this anymore. So the analytical piece says I want to be able to manipulate the expression somehow. When I can't divide by sine x, because remember, you can't divide by a variable because you're possibly dividing by 0. But I can factor out a sine of x. And that leaves me with x minus 1 in parentheses, and all of a sudden, it just pops out. So because the product is equal to 0, that means each expression could be 0. And if you remember, sine of x is equal to 0 at all of the integer pi's. So I'm going to say x equals 0 and x equals pi. And if x minus 1 is equal to 0, I see x is equal to 1. And there are the solutions. So this one wasn't so bad analytically once we saw what to do. Thanks for watching.